This is Hacker Public Radio episode 3174 for Thursday the 1st of October 2020. Today's show is entitled Linux Inlaws Season 1 Episode 14, The Big Programming Language Panel, and is part of the series Linux Inlaws. It is hosted by Monochromec and is about 53 minutes long and carries an explicit flag. The summary is: our heroes host an eclectic panel of experts discussion C++, Python and Rust.
This episode of HPR is brought to you by archive.org. Support universal access to all knowledge by heading over to archive.org/donate.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open plan office or similar environments. Any minors under the age of 35, or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs. And this is Linux Inlaws Season 1, Episode 14, the big programming language discussion. Martin, how are things?
How are things? Things are great, except for the Python script that someone wrote that crashes my Audacity. So, which is quite an intro to our programming languages special. But there we go.
Martin, just don't blame it all on Python.
No, I'm blaming on the author of the script.
Full disclosure, Martin is talking about me because I wrote the script. Martin is using probably some Windows, trying to get Python to run on Windows.
No.
Because his Audacity version is also running on Windows.
Not this particular Audacity, actually. But there we go. News. Okay, news. Yes, so news that ties in rather nicely with our programming language episode. And something that you will particularly be also fond of hearing is the fact of the new operating system AWS has introduced called BottleRocket for actually written in Rust. So this was a complete... well, BottleRocket wasn't a secret, but that it was written in Rust is news to me. And so it is entering... if the bookshop is actually using a programming language to write OSs in, then we're on to something quite significant. What do you think?
Interesting perspective, given the fact that there's another one called Redux OS.
Uh-huh.
People, we might be tempted to do a special before the year's over on operating systems written in Rust.
Both of them. Oh.
Yeah, both of them, exactly. So what exactly is BottleRocket then, Martin? Explain a little bit more, please.
Okay. So AWS has decided to add a Linux for containers, basically. It's a cut-down version. For containers, you don't need every package under the sun, right? You just want an OS that can run a container. So, being at AWS, this code has obviously not been available, unless I have been looking in the wrong places. So the exact details of the contents of this OS are, as with all things AWS, quite well hidden. But it sort of taunts improved security with remove packages with packet filters, kernel monitoring, etc. So they've done a fair bit of extra bits around making those specific security concerns addressed in a container OS. What it looks like.
Cool. And this is in production right now?
Yes, it's been released as GA now, isn't it? So it has been talked about for a while. But So the whole, I think you mentioned earlier, which we'll come on to your news in a minute, but the whole Rust thing seems to be, as we'll find out from our guests later on, seriously on the up as a language.
Along these very lines, there was something called the Linux Plumbers Conference in late August, where, and you'll find the details, of course, people in the show notes, where a couple of people have taken serious steps to lay the infrastructure for the inclusion of Rust codes beyond drivers in the Linux kernel. The infrastructure work seems to be quite advanced. Even the upper echelons are not talking about not replacing the whole kernel with the Rust implementation, but rather seriously evaluating whether to implement new functionality in the Linux kernel in C or actually Rust. They're already talking about modifying the build system to incorporate Rust. And given the fact that this is one of the kind of early steps, work seems to have progressed quite a long way already, meaning I wouldn't say that the Linux kernel is ready for prime time for Rust now, but the serious steps are being taken as we speak. Given the fact that we're talking about a code base of about 25 million lines, and with a technical heritage, for want of a better expression, of about what, Martin? 30 years?
Yeah.
Almost. That's a long time. Don't hold your breath with running with Linux kind of purely being implemented in Rust or re-implemented in Rust, because that certainly won't happen because of the sheer size of the code base. But going forward, it wouldn't surprise me to see more and more fragments written in Rust entering the Linux kernel code base. Something very interesting.
Yeah, definitely. And by the way, I stand corrected on my previous comment. Bottle Rocket is in fact an open source project, so all
cool
is available on GitHub.
Excellent. What else do we have for news? And in slightly different news, Martin, you are running Windows, right?
I'm running 4 different OSs. One of them being Windows, yes.
Excellent. You'll be glad to know, Martin, that Windows has now achieved a rolling release status.
Okay.
Similar to font Linux distributions like Arch and so forth, Linux is now a rolling release. Given the fact that I had the impression that Windows was although Windows 10 apparently will be the last Windows version as officially distributed by Microsoft, I had the impression we were talking about half-yearly upgrades, similar to, for example, Canonical does it with Ubuntu. So you have the 2004, you have the 2010, you have the 1904, and you have the 1910. And no, but I was corrected in that assumption, because the well-known Ubuntu podcast, as in season 13, episode 23, Alan Pope revealed it all. Alan actually compared, Windows to a rolling release approach. Something very interesting given the fact that Windows only issues, I think, as I said, half-yearly updates. But Martin, maybe you can elaborate on that, given the fact that you are a Windows user.
They may release many releases, whatever they like, but one of my previous Windows machines is still running XP, so I'm not one to talk about releases.
Martin, in that case, if you're still running XP, you'll be glad.
I may adopt a different strategy with Windows 10.
Yes, Martin, if you're still running Windows XP, you'll be glad to hear that an upcoming episode of Linux Inlaws will talk about IT security.
Well, it's very secure because it's not connected to any network.
So you're running this self-sustained on solar power? Excellent. If it's not connected to any network at all. Wow, interesting.
Yeah.
Can you send pics?
We can do, yeah.
Excellent. Okay.
That's probably turned off as well. So
which probably should
very secure.
Yeah. Which probably should be the default setting for any XP system still out there. Yes. Other news. Yes. Thunderbird 78 now includes OpenPGP. So for those aficionados out there still using Thunderbird or are using Thunderbird once again, you do not need plugins like Enigmail to securely send your mail, because now Thunderbird includes already OpenPGP per definition out of the box. So simply upgrade, import or migrate your Enigma mail settings to OpenPGP, and Thunderbird actually takes you by the hand and does it for you, or does it with you rather, including key migration, all the rest of it. So that process is really straightforward.
Cool. And
the last bit of news from my side is actually Fedora is serious about getting ButterFS into production, because they're looking right now for testers for Fedora Core 33 for ButterFS. So if you have a couple of spare cycles, you'll find the link in the show notes. Give that project a hand.
Okay.
Anything else from your side, Martin?
Well, if you're interested in the history of Linux in a nutshell, there's a handy a link in the show notes, handy document someone's written on this subject. So if you want the last 29 years of Linux in a nutshell.
Cool. Yeah, please send me that link, and I'm going to include it in the show notes. Okay, if there's no other news, let's continue with our special on programming languages.
Yes.
And over to the panel. This is Linux Inlaws Season 1, Episode 14, the big programming language panel. Welcome, gents.
Thank you.
Martin, over to you.
Yes, welcome, Jeff and Mike. Would you like to say a few words about yourself before we get started on the programming languages themselves?
Who should start?
Yeah, or Jeff. Go, Jeff.
Oh yeah, so my name is Jeff Bland. I work currently in the VR and eye tracking space in Tokyo, and before that, almost 10 years in mobile app development. I'm just a long-time C++ programmer. I occasionally tweet about C++, and yeah, I think that's all you need to know about me at this point.
Thank you, Jeff. Mike, yourself?
Yeah, my name is Mike Müller, and I'm a Python trainer. So I spent the last 10, 15 years mainly teaching Python. So I do have a scientific background. Therefore, also a lot of my Python course participants are scientists. And in addition to being a Python trainer, I'm also pretty deep in the Python community. So I'm an organizer of a bunch of Python conferences, and I'm still involved in Python conferences and everything that has to do with Python.
Okay, and finally, thank you, Mike. Finally, since we did not, we had a cancellation on the Rust front at the last minute, our own Christoph Zimmermann will be covering the Rust language.
Indeed, my name is Chris Zimmermann. I'm the co-host of a podcast called Linux Inlaws. Have been doing Rust for the last 3.5 years, maybe. And also gave presentations on Rust at this year's FOSDEM, all the rest of it. More later on this beautiful language.
Okay, thank you, everyone. So I'd like to start with a little bit of history on each language. So where first of all, where do you think it came from? Where do you think its purpose is? And how did you yourself get used to it? So if we stick to the same kind of sequence, and then we can open it up for more discussion after that kind of first intro on the languages for those not that familiar with them. That's okay. So Jeff, please, what would you like to say about C++?
Well, first let me say I'm not a representative of C++, of the greater community or anything like that. So I'm just sharing my own opinions today. But C++, I think everyone's at least aware of kind of what it is to some extent and what it's for. But it's a rather old language. But the thing I want people to understand is that it's changed a lot, even just in the 15 years or so I've been doing it. It's changed quite a lot. C++ 11 was a huge update. 14, 17, and C++ 20, which was recently standardized, have also changed the language significantly. And I think really it's like best features, or not features, but its area of applicability is probably large code bases that need to be at least somewhat performant. So in my, where I began with C++ was in game development around around the year 2000. Although I started as a hobby programmer, so I don't know the exact date. But it's still extremely relevant in that field because the type safety, the abstractions that it provides for high level usage, but at the same time still being performant, are really useful in that space. And nowadays I'm using it in the VR space as well, where I think it's still a really good language for that. And of course, there's tons of companies out there with huge C++ code bases. And so I think really that's where it excels. Like I wouldn't, start a C++ script just for, moving files around or something like that. I would use another language for that. But when it comes to I'm going to write this big thing that's going to last for 10 years, I think C++ is a really good choice.
Yes, I would agree with that. And so in my experience from coming across C++, it tends to be in the high performance finance space as well, where people choose that as a language. But have you come across that as well? That it's I think you said already, it's mainly chosen for performance, right?
Yeah, absolutely. I do think Rust can present some challenges to C++, so maybe we can get into that today, because Rust also has a lot of similar goals. Where it's performance, it's still high level. It's not like C. It doesn't have all the dangers of having to write inline assembly or C like that, but you can still make really nice high performance programs. I'm curious to see, because I haven't worked on Wall Street, for example, if there's been adoption of Rust there, but I still think that's the general domain of C++. So.
Very good. Very good. Okay. That's a very nice introduction to C++. So let's move over to Python, and rather than getting into the Rust debate to start with. That's okay, Mike. Would you like to do the same?
Yes. So Python actually has a kind of a birth state. There's a nice anecdote. Guido van Rossum, or probably if you pronounce it Dutch, it's Guido van Rossum. He's the original developer of Python. He didn't have anything to do between Christmas and New Year's 1989, and he developed Python, which I guess is partially true. He worked at a research institute in Amsterdam at the time, and he was heavily involved in language development. And then they put a lot of pieces together, and Python at this time kind of settled in the niche between C as a system program languages and Perl, a language you can only write and never understand again. So Perl has that kind of reputation. I'm being funny here. But Python settled in this niche to fill this one. So easy to understand. It has a background in ABC, which was a teaching language, a toy language. So the syntax, indentation. So it should be very easy for people to get in, but at the same time also good enough for professional people to do some real work. And that's actually one of the interesting features of Python. That's how it developed. And I think the first public release was 1991 in March. Yeah, so Python is going to turn 30 soon, actually. And it was pretty small. And I got involved in Python in 1999. I still remember I bought my first book. At this time, there was the second German book came out, and there's like 5 English books. Now it's like 500, I'm sure. And I bought this one in April, and I needed it to actually do scientific programming. It was back in my days at a research institute, and I had a couple of numerical codes. And the first thing I did with Python, actually, I wrapped Fortran. So Fortran is existing code, been there for decades, very performant, but really difficult to use, and wrapped the whole stuff in Python. And I wrapped the other thing in C in Python and just put everything together. So I glued 3 numerical codes together, and I did it in Python. And that's one of the good, interesting areas of Python, so-called glue language application. So you use Python to glue together existing systems. And that's, I think, where Python shines, because Python itself, C Python, we can talk about implementations, is implemented in C, and you can easily connect with C, and with C you can connect with many other languages, and there's also connections with Rust nowadays and many others. So you can also talk to Fortran, and in a kind of more or less convenient way, so you can exchange data and you wrap it. And that's how I started with Python. And I've been involved in this Python for quite a while now, since 1999, and then I got into teaching because I was in university and taught some lectures there already. And then if you teach at university level already and you use Python, then doing Python training is a kind of something that makes a lot of sense. And Python, the language, is interesting. It's totally open source, and it's used in many different areas. There's not only one area. It's used in pretty much everything. So web development, all kind of scripting things, all this cloud, many cloud solutions use Python a lot. Scientific area, there's a lot of scientists that use Python for a long time. That's where Python has a lot of libraries. Machine learning, which is kind of data science, which is kind of connected to science. It's one way or the other, but also web and many, many other things. You can find Python pretty much everywhere. I even heard that one guy implemented a toy operating system in Python, which is probably not the best domain for Python. But it works. He used MicroPython, which is a Python especially designed for microcontrollers, a very different implementation. Because Python has 2 things. It's a language itself, and has a reference implementation, which is C Python, which is probably 98% or 99% people use it. And there's a bunch of other implementations like PyPy and MicroPython and a few others that are not that common, JSON, IronPython, or Python for .NET, and so on.
Okay, so that is so. I think from what I'm hearing is that you're saying that Python is great because of its variety, number of libraries, and application of uses. Right now, that's its main strength.
So there's a saying: Python is the second best language for everything. So that means Python is good in pretty much every area. Maybe not the very best, but you have the advantage you can use the same language if you want to write a web application, or if you want a HPC, high performance cluster, or if you want to do some cloud development or whatever you like, you can use the same language, and you have very powerful libraries that in addition wrap libraries potentially in other languages that you can take advantage of this functionality also without switching the language.
Yeah, no, that's great. Obviously, the fact that it's been open source makes it quite transparent. And have you been following the kind of the project as well, and all the development around Python over those years? Right.
There's 2 things. There's one thing is like there's the Python Software Foundation, which is a kind of copyright hold of Python, and they do all the administrative things. Like they do the Python conferences, collect money, and distribute it back to the community, supporting open source projects. And there's a core developers. So I'm following some of the lists. I'm not myself a core developer, but I'm following those lists and kind of follow what people are doing a little bit. And it's a very interesting way. So Python ideas, for instance, they talk about new things that might become part of Python or not. And I'm following this a little bit. It's a very interesting project because Python doesn't have like a specification but has a reference implementation. It's a bit different approach than C++. So there's no kind of board people coming together and setting the rules, but they have this process called PEP, a Python Enhancement Proposal. So if you have a great idea, what should become part of Python, you probably should join Python Ideas and discuss it there. And if it's good enough, you can write this PEP thing where you describe what you want to do, how you want to do it, and if possible, kind of a reference implementation. So that's how it works. And then you need a sponsor from the core developers that supports your PEP, and there's a kind of a semi-formalized process to get it in. That's pretty interesting, and it seems like it works pretty well because Python wants to strike the balance between be able to do a lot of things, but don't have too many features that you kind of get burdened by all these many different ways of doing this. So Python want to have one preferred way of doing something. There's always many ways of doing things, but usually there's one preferred way, and you want to kind of not to have too many ways doing the same thing, which makes it more difficult for people to learn.
Yeah. No, that's great, Mike. Sorry, we did do a couple of episodes on Python, so we want to try and give a little bit of speaking time to Rust as well. Thank you for that very much. So, last but not least, our own Christoph on Rust.
Yeah, thanks. Having used all the two remaining languages, i.e. Python, I totally see what Jeff and as well as Mike are referring to. The first big project that I actually did in C++ was the meta-level architecture for the experimental microkernel that I was developing as part of the PhD. And we did the kernel in C as well as C++. And I learned C around, at the tender age, I think, of 14 or 15, something like this. All through my uni years, I've administered Unix Unix system because Linux wasn't around then. So that was also the programming language of choice for my bachelor thesis. So yeah, I've been growing up using C and C++, so I can totally see what Jeff says. But then as part of the PhD, we were also looking for a scripting language to do much of the QA framework with. And so I came across Perl and Python. And suffice it to say, I've been using Python since the early days for, as Mike rightly outlined, for gluing stuff together. In terms of Python has a significant ecosystem. And for me, programming in Python is basically taking a look at what's out there. There's something called the Python package archive, or index, my mistake, and then simply writing the glue code that ties together these modules. Similarly, Rust has also filled this niche in terms of within the last 10 years. I think the first commit was about 11 years ago. Okay, let me shed some more light on the history of Rust. About 13 years ago, I think 2007, something like this, Brian H. and friends at Mozilla were looking for an alternative programming language for the implementation of what was then the rendering engine for something called Firefox, which is, I think, a browser, if I'm not completely mistaken. Jokes aside, if you take a look at the implementation of much of the code base of Firefox up to that point, you'll see a very large code base, and Brendan and friends clearly saw the rising technical depth with that code base, never mind the more and more effort that they had to pour into this code base for QA. So they basically took a look at what's out there and decided to do their own language, not trying to repeat the perceived mistake. Is probably a too strong word for this, but you'll see this actually at some of the language aspects of Rust. To do it better, let's put it this way. So Rust, for example, has a strong typing system, is a compiled language, and has a couple of unique traits that basically allow moving of much of the testing effort that you would typically do after a build to the compile phase. memory management probably being one of the primary examples in this case. So the old adage still applies. If you can convince a Rust compiler to generate code to produce an executable binary, you're almost half there, because Python, you just write a script and then hope for the best once you execute it. So one of the main philosophies behind Rust is to move this effort from the QA phase to the compile phase. And I'm happy to say that the ecosystem that it probably took Python to develop for 15 years or something like that, maybe even 20, in Rust has been done more or less over the last 10 years. If you take a look at the package index on the crate.io side, it's pretty comprehensive. Python has 4 or 5 web frameworks. Rust, within 10 years, has developed 3 main ones, and it's still growing. So I'm really looking forward to the discussion between the 3 languages, having used all 3 of them.
Yeah, thanks for that, Chris. That, as Jeff already alluded to earlier, he thinks that Rust may be posing a challenge to C++. Have you been using any Rust yourself yet, Jeff, or just from a studying point of view?
Just from a studying point of view. I've written little scripts and things like that. The trouble is, like with C++, usually we're working on large code bases. So I think really Rust is going to sneak in like individual modules, like the next version of our firmware at our company or something. If we have a good chance to restart, I would consider doing it in Rust. But we just have so much C++ code that it's hard to just have a completely isolated place where we can start a Rust code base. So I think that's one of the challenges for Rust.
Yes, do you think that's going to be a problem going forward for adoption of the language as well? That if people do have those large code bases in C++, then will there be a place to start even adopting Rust? Right? It's people have skills, companies have invested in a certain technology, then changing no matter what technology, whether it's programming languages or databases, right? They want to maintain that investment. Is that why we're not seeing so much of an uptake of Rust so far, do you think?
I think that's part of it. One is the existing code bases. 2 is, as you mentioned, like training. Like just even within my company, we have, it's mostly a C++ code base, but you also need to know Python because there's various scripts. You need to know a little MATLAB. You need to know C because there's various bindings that go through C. And it's like, if I add Rust to the code base, that's yet another language that we have to train people on when we hire. And so that itself is a problem, I would say.
I'd like thanks.
I will say one thing though. If you ask for Rust programmers, you get, I would say, and this is my opinion, I don't want to offend anyone, but you get a really high caliber programmer. Like it really weeds out a lot of bad applicants if you put Rust on the requirements list for what you're looking for to hire, or at least the wish list, things that you would like to see in an applicant. That's just something I've noticed so far.
But Jeff, you get all the numbers.
Is that why you added it, Chris?
But Jeff, you get all the nutters, the kind of the hipsters drinking coffee, drinking soy lattes in hipster coffee shops. No.
Yeah.
But a lot of them know what they're doing, which is interesting.
Indeed.
No,
I'll come back to you in a minute, Chris. Let's get to Mike's view on the
of course. Sorry, yes.
Opinion as well. Sorry, Mike. What's your view on the Rust versus C++ debate?
Yeah, I think it's interesting for me. If I understand right, Rust adds this security. So in C++, you can, if you want, massage the memory and do pointer kind of stuff. Which in Rust, if you do this borrow checking thing, I'm a layman in this thing, gives you a lot of security. So you can achieve pretty much the same performance in Rust as in C++ without potential problems with seg faults and all kind of problems. And actually, if that's right. So in short,
that's a very interesting perspective, Mike, because I presented some background. I presented a paper at FOSDEM this year. Sorry, not a paper, but a presentation outlining what Redis Labs did with something called Redis JSON 2. It's a module running on top of native Redis. Modules are application-specific extensions for databases running on top of a very popular NoSQL database called Redis. And essentially what these modules do, they turn native Redis into an application-specific database, like a database able of handling documents, of handling graphs, of handling full-text search, and so forth. And the first iteration was actually done in native C of Redis JSON, because C is the program language that the project founder used to implement the server, as well as some of the initial extensions as in modules. And then the total re-implementation was done in Rust. So what the lads did down in Israel, actually, they wrote a crate that essentially implements the module SDK, so allowing you to then write modules in Rust using that SDK crate that natively then talks to the server. And the performance overhead that you paid when using Rust instead of native C was only on the order of 5 to 10%. It's something that I found pretty interesting from a security perspective, because in contrast to native C, where you have to do much of the memory management manually, because this is basically what C gives you. C++, of course, is a little bit different here. But in contrast to this, Rust basically takes you by the hand, and it won't generate code if the memory management is not up to scratch, because it does manage the memory for you more or less automatically. And essentially, you have to know what you're doing in terms of, for example, there's a concept of an ownership, where Rust ensures that at any given point in time, only one scope actually owns a piece of memory. That can, especially for people who are at the beginning of the learning curve, that can be here a challenge here and there, because some of the concepts, especially if you're starting off with programming, can be hard to grasp. But moving on, what I feel interesting is actually, and that goes back to Jeff's comment, there was a proposal about 2 years back where some chap, or it's actually two of them, started to write Linux device drivers in Rust. That led to the ultimate comment by somebody called Linus Torvalds that he sees Rust entering the kernel space more and more and more. Now, if you take a look at the Linux kernel, you'll notice that Linus started this, I think, with 12,000 lines of code in 1992. And I think the latest metrics coming from the Linux Foundation clock in at about 20 million lines of code these days for a Linux kernel. It's interesting, and I would like to get the perspective of Jeff and Mike on this. If you see any other traditional large code bases, such as the Linux kernel, basically opening up for new languages, and Rust, I think, it would be one of the examples here.
Well, I think Firefox, like you mentioned, is another obvious example. I mean, there's a huge amount of infrastructure that's just everyone uses, right? Like these major open source projects, OpenSSH, Linux, all the browser engines. I think any of these, especially places where security is relevant, are good places, or I don't know if they are, because I'm not involved with all these projects, obviously, but are good places to consider allowing Rust, or writing like bindings or things where other people can start adding Rust, at least around the peripheries, even if we can't rewrite the code bases. And like I said, I think where security is especially relevant, such as the kernel, such as browsers, I think that would be a very wise choice.
Okay, Mike, what about yourself? What do you think about the...
Yeah, I think, of course, I have to speak from the Python perspective, or I will speak from the Python perspective. Nowadays, let's take the scientist field as an example. So, of course, I have a lot of contact with scientists, and traditionally they use C++, Fortran, these kind of languages for their computations. But more and more, they realize that they have performance problems, but very often the performance is only in a very small area. So they have a solver for PDEs, for partial differential equations, for instance. And this is sometimes a few hundred lines of code, but the whole program is many 10,000 lines or more, 100,000 lines of code. And very often there's no need to write the whole application in C++ or Fortran, just because you need this few hundred lines fast. And that's probably the trend, that you keep the solver in a compiled language and write the rest in Python, which is usually not performance critical. So moving files around, and Python has so many libraries that it does it again, and that's where it goes. And nowadays also there's a lot of libraries that in Python, you use Python, but they generate new code. You write Python code and they generate code in the background, like Number is one of these things. It's something that can generate native GPU code, for instance. So you write Python, and this has a nice thing. It generates performant GPU code, because programming a GPU is something, if you look at this, it's a total science itself. You don't understand anything if you have no idea how GPU works. And very often as application programmer, you don't want to get in this field. And that's probably a trend now, that Python becomes a front end and generates code in other languages that will be compiled. So it's like meta programming, if you want. And then you take away the burden of fiddling with all the details, because very often you're not really familiar with all the details, because you write your application and you're not necessarily an expert in one of these low-level fields like GPU or something else, or compilers in general. They need to know all the things. And those tools very often do a better job than some person who's not the total expert in this field. And that's how I see how this probably goes.
That's an interesting perspective that I hadn't considered that one. And what you're saying is that these generators are of a certain quality that would, be over and above what a core programmer would produce.
Yes, very often it's better. So if I would write GPU code, probably I know a little bit about GPU code and try to do it by hand, just for fun, just for testing. Probably won't be as good as the generated codes, because they can kind of generate, like if you do this, you can do something like generate different kind of versions and compare them internally and take the fastest one. Yeah, so kind of a little bit just-in-time compilation. So they can inspect, because they have a lot of information, and they generate an AST, an abstract syntax tree, and they can inspect it and make it better, and can do a lot of things which a human wouldn't be able to do probably, or wouldn't do it because it would take too much time. But the machine can do a lot of things, and in a few minutes can rearrange everything and try different versions and all kind of things, and which is often better than the average application programmer. If they have a very expert in the field, that is a GPU programmer, knows everything, they might be able to write faster code, but this would take a long time, would be very expensive, and then we have to change the code manually. And in the end, it wouldn't pay off. Like, who's writing assembler nowadays? Very few people write assembler. 30 years ago, many more people wrote assembler, but nowadays the assembler is just generated, and very often the generated assembler is faster than manually written assembler, I would say.
No, that's a good point. Good point. Chris, what about your opinion on that? You having experience with writing assembler and many other things, do you think a generated piece of code can be of the same level?
I fully agree with Mike, yes. If you take a look at projects like LLVM, Clang, of course, being the C front end here, or if you take a look at the code generator that Rust uses, it uses a slightly modified, I think, LLVM backend. It's hard to beat this. GPUs are, of course, slightly a different story, but I think even there, Kuda and friends have made great leaps in the last couple of years. Jeff, if I'm completely mistaken, you're coming from you're coming also from this embedded area, right? What's your perspective on this?
I would actually agree on the inline assembly. Anyways, it's really, really, really hard to compete with the compilers, and part of that is that the instruction sets are so complicated that there's a lot of optimizations that the compilers can make that you don't even realize, especially if you're just sort of learning it just to write some inline assembly in the hopes that it's going to be faster. Back when I did mobile apps, like for the earlier iPhones and Androids that were using RV7, RV6, we did do inline assembly. And there were certain things like matrix operations and things like that, where we could write it faster than a compiler could generate, just because we know the tricks and they're well known. But outside of that, you really don't want to do it yourself unless you're really an expert and know what you're doing. The compilers are very good. And kind of the introduction of LLVM as sort of an intermediate language for everything has actually, I think, really helped, because now there's tons of things that can compile down to the bytecode, and then let LLVM deal with actually generating the machine code from that. So in a way, we're kind of in this cool golden age, I think, where you don't have to go that low level, but you can still get the performance, and almost everything can, in some way or form, be compiled down to something that's efficient.
Sorry. For the people who don't know what LLVM is, LLVM, if I'm completely mistaken, stands for low-level virtual machine. Essentially a compiler ecosystem that has various language-specific front ends like CLang for C and C++, similar to GCC and friends, with the main difference that LLVM, as Jeff just outlined, is a standardized, more or less, intermediate language as an intermediate representation that LLVM then simply takes and produces optimized machine code from this. So the idea is basically a language-specific front end takes the programming language of choice, like Java, Golang, Rust and so forth, produce an abstract syntax tree which is ultimately converted into the intermediate representation, which is then picked up by LLVM. Quite a few projects use LLVM these days as their standard compiler framework. For example, if you pick up something called Xcode, produced by a company called Apple, if I'm not completely mistaken, what used to be GCC is now LLVM and CLang as their main compiler drivers for C, C++, Objective-C, as well as, if I'm completely mistaken, also Swift.
That's right, yeah.
So that's the way it works these days. But I found this interesting, Jeff, that you said that you actually, in the olden days, you did assembly on mobile devices, because essentially what that means, you're circumventing the JVM on these early Android implementations, for example.
Oh, well, the stuff we were doing was C++ anyways, using the NDK.
Okay, got it. Okay, fair enough.
And in those days, we wrote everything in C++, which is still what game engines do. And then we just had bindings to Objective-C++ or Objective-C, in our case, Objective-C++, because you can inline it with C++. And then you have a Java wrapper for the Android side, but everything's in native code. Especially in those days when the phones were kind of like N64 level, like not particularly fast, just barely fast enough. Of course, it's been exponential how fast the hardware has improved in the mobile space. But yeah, at that time it was still very useful to write at least very targeted functions in assembly. Although a lot of that stuff is actually just standardized in certain libraries, right? Where if you're using a math library, it might have hand optimized matrix multiplication. If you're using SHA-1, it's probably going down to something that's really optimized, as long as you didn't copy paste some code out of Stack Overflow.
Yeah, got it. Before we move on to that was a very interesting discussion. Thanks for that, guys. Before we move on to ecosystems, I'd like sort of a very quick two-liner around how do you see the future of each of these languages, yourselves having gone through many years with them, growing up with them. But what do you think of in 5-10 years' time? Where will we be with each of these? So, Mike, I'd like to start with you.
Yeah, so prediction is always difficult, especially if they're about the future. And
very good, I like it.
But I would say one thing is,
opinions are fun. Yeah,
yeah, that's my opinion. One thing is there was a blog post a while ago, because you might know that the switch between Python 2 and Python 3 was a bit difficult. So this is Python develops, yeah. So there's essentially no difference between Python 1 and Python 2. Essentially, Python 1.6 and 2.0 is technically the same thing. They just changed the license, but there's a big difference between 2 and 3. So they cut off a lot of backward compatible incompatible things. So just something they didn't like. They said they turned out that's not good, and now we want to change it. And if you change it, it's not compatible anymore. and they changed quite a few things. And that was a big thing in the community because they just thought people just switch from Python 2 to Python 3, but it didn't happen. And a lot of people had to maintain libraries. A library was for 2 versions for many years, for more than 10 years. So Python 3 came out in 2008 initially, and now we are kind of over the thing. Everything's Python 3 pretty much. Not everything. There's still a lot of consulting business to so if you want to make money with consulting, you should consult for Python 2 support. Yeah. So there are still quite a few legacy things that go behind it that never wanted to change. I think YouTube is one of them. I'm not mistaken. So I'm not, but that's what my last information I had. That YouTube is partially written in Python 2, and they maintain their Python compiler, if I'm not mistaken, so interpreter. And this would be something that's not going to happen with Python 4. That's the future. So Python 4 will be backward compatible to Python 3 to a large degrees, and also there's no Python 4 on the horizon, as far as I'm aware. There will be now Python 3.9 is coming out, and there will be a Python 3.10 likely in the Python 3.11 and so on. So they go with 2 digits, because Python 2.7 is the last 2.7 version. So that's something they want to make it more compatible. And seems like Python is kind of now very interesting language because it's a language that scales. So you can, as beginners, start programming with Python, and with very small subset of Python, you get something done. But I've been using Python now for 20 years. I'm still learning, and I teach advanced Python training with meta programming and stuff. And there's a lot of funny things you can do, but very few people actually need it. Yeah, so meta class is something I haven't never used in production. So even if I've studied them quite a bit for the training, but there's very few use cases for these things. So it's a language that kind of scales pretty well. And it makes it interesting for a lot of different applications. So the typical user who switches from using Excel for data analysis to Python is one end, and the other one is writing very sophisticated AST, abstract syntax tree formations, and converting Python into other languages and doing all kind of these kind of things. And I think that's one of, we talked about it already. So Python has a lot of ways to connect with other languages. Python is a subset of Python or superset of Python that can translate Python directly to C. In addition to wrapping C and C++ libraries, there's Python in Rust. Yeah, there's Python in WebAssembly, Pyodide running in the browser, and if there's another language, there will be another binding. So that's probably one way that Python continues. And it will be very often the go-to getting started language for programming. I think a lot of universities nowadays, they switch to Python as a programming 101 language, which used to be Java or sometimes even C++. But Jeff might agree, somebody who never programmed before starting the C++ might not be the best experience in terms of how fast you can progress. Yeah, so Python is way more approachable, I think, because you can just start doing some very small scripts that moves your files from left to right, and it's doing something useful. And then if you want, you don't even write a function if you don't want to in the beginning. And then you can learn how to write a function and maybe how to write a class. And you can go gradually and can learn. And you can use a lot of libraries. That's the other thing, which is Python's totally expanded. Like you have like 250,000 libraries on this Python package index, PyPI. Yeah, there's a PyPI and there's a PyPy, which is a different Python implementation. Don't confuse the both. So PyPI, Python package index, and has a lot of libraries for pretty much everything. So if you have a task, you think this problem somebody should have had it before. It's very likely that there's a library out there that is doing it very likely much better than you can do. The only thing you have to find a word how to search for it. The search in PyPI very often gives you many hits which are totally irrelevant. So the search is not that good yet. So very likely a Google search might be even better, because Google has some different algorithms to search. But very likely once you spend like half an hour searching and evaluating different options, you probably find a library that is solving 80 or 90% of your problem already, and you just have to write to Rust.
Yeah.
This will continue.
I think this is something that Chris has done himself, right? Yeah, a lot of times he mentioned that if there's a piece of code he needs to write, he'll go on and collect various bits out of PyPI and modify them, glue them together. Would you do the same with Rust with the crates approach?
Absolutely. In contrast to Mark's observation that predictions are hard, especially if they're about the future, I'm happy to report actually, since now I got the flux capacitor
You got it working. Right.
Yes, indeed. So I'm happy to report that in about 5 years' time, Rust will have taken over major portions of the open source language ecosystem, ultimately resulting in a version called Linux, 10.5, which basically now contains, and we're talking about the year probably 2034 or 35, will contain about 70% Rust. The rest is still C legacy code. Python will have a niche existence, mostly confined to big data. And C, yes, or C++, maybe mobile. But Rust ultimately will take over the universe. No jokes aside, people. Every language has their own specific purpose, has their own specific kind of target audience. And the idea when Brendan and friends basically about 10 years ago, basically sat down and did this Rust thing, was to come up with a performant low-level language aimed at system programming, because essentially this is what they did when they sat down and wrote something called Servo. Given the fact that the ecosystem is growing by leaps and bounds, something that took Python about, 20 years, Rust took only, the Rust ecosystem basically took about 10 years to reach, I wouldn't say the same level, but pretty close to it. Going forward, I see Rust basically entering more and more, I wouldn't say just low-level use cases, but also kind of system domains. Let's put it this way. You'll see this actually if you take a look at the current developments. The Tor project, as in the Onion router, basically is toying with Rust. Microsoft has just discovered that Rust is actually a programming language going forward, which is very interesting. There's a presentation. You'll find the links in the show notes. You find the link in the show notes. There's actually a presentation from Microsoft about a couple of months back, where they said they are actively evaluating Rust in the number of projects where previously, and Jeff probably agrees, C and C++ were the languages of choice for Microsoft to implement their applications and operating system. For example, much of Office is actually written in C++ as a Microsoft Office. Going forward, they made different choices. For example, Visual Studio Code is mostly written in TypeScript. Python is done too at Microsoft, but it wouldn't surprise me that in about 5 to 10 years' time, you'll see much more, not only cloud stuff as in Azure and friends, but also native applications emerging from Microsoft being written in Rust. And you'll see a broad adoption of Rust all over the place. And Tor, Microsoft are just being 2 examples here, plus, of course, the Linux kernel.
It's a very bold prediction there. What's your view on this?
It's not a prediction. It's the truth.
What do you think, Jeff? Is there anywhere close to the truth?
I don't know if that's the truth, but I think it would be a good truth, a good future. I mean, part of the reason why I like Rust, I think, is because it solves some of the biggest issues that we have. Like when I use software, I mean, the 2 biggest problems I have in general are 1, it's too slow, and 2, it's too buggy. Right? And so like what we need is like programming languages that attack those 2 things primarily. And that means performance has to be key, like a central part of it. And then like, safety, and Rust is all about safety. And like, that's part of the reason I like C++ is that in some ways we're allied. Like if you look at a lot of the things that they've added to C++, all the zero cost abstractions, all the higher level stuff that gets like brought down in the compiler to like really efficient code. That's similar to what Rust is doing, but Rust is like a clean start, right? So in some ways I see it as like C++'s little brother. I don't know if Rust likes to be seen that way, but to me as a C++ programmer, that's how I see it. And I want that little brother to eventually take over.
Grow
right?
up, yeah.
Because the problem with C++, and I was kind of reminded of this when we were talking about Python 2 versus Python 3, is that they will not break backwards compatibility for the most part. I mean, there are like, you can craft a program that will work in older C++ that will not work in newer C++, like if you intentionally use keywords that were added later, things like that. But for the most part, they won't do that. And that's because so many of the people who influence the committee work on large code bases. And they're very aware of that. They don't want to break anyone's code. So they'll do things they'll acknowledge that null is bad. We inherited that from C, but the fact that it's an integer and a pointer, right, and a Boolean, like that was bad, right? So they introduced null pointer, which is targeted to one use case, right? But then they didn't get rid of null, so now there's all this cruft. And part of the problem is that they can say like, you only need to learn the new stuff, but in reality, you're working with code bases that have existed for a while, and you actually have to learn both the new stuff and the old stuff. I mean, you'll never have to learn everything because there's part of the C++ philosophy is like everything is possible. We will implement like whatever it is, any crazy way you want to do something is supported. But yeah, that it's both a blessing and a curse, right? That like we can't get away from some of the core issues that were introduced in the language or that were inherited from C.
Yes and no. I mean, obviously the standard keeps evolving even with C++, right? And I mean, Chris mentioned, so adoption in Tor and potentially Microsoft, but there is obviously a large amount of backing for the language, right? Which is more proprietary perhaps than for Rust, but as such, the language will keep growing as well as and evolving, I'm sure.
Oh, it is. Yeah. Well, so like, that's the other half of what I wanted to say, is it is a very rapidly evolving language, and it's a very exciting language, at least for me, in that like, right now I'm working in C++ 14 primarily, just because we don't switch to new things until we are sure that every platform, every random compiler that we might have to use, supports it. But there's like every day I'm like, oh man, there's this stuff in C++ 17 I wish I could use, right? I wish I could use standard optional. I wish I could use, like initializing two variables from one function call, things like that. And it's just like literally the day-to-day stuff that I do is better in C++ 17 or would be better if I was using it. And the same is true for C++ 20. So like a lot of things they are working on are really are day-to-day things. Cause I see a lot of criticism on the internet, like, that they're off like messing around with templates that only matter for, people who write Boost or certain libraries. And that's not really true. Like the way I write C++ now is very different from the way I did it 10 years ago. And I'm very certain it will be different 10 years from now. Different and better, I should say. So for that reason, it's really exciting because there was stuff that was like standardized 3 years ago that I'm still not using, but I know that they're there, and I'm excited when we approve it in our code base, that my life will get immediately better, and that they're working on the next things as well. And the fact that they won't break any of my existing stuff is actually pretty nice. So yeah, I think it's a really fun, interesting, and exciting place to be. In the C++ world. So,
quick bold question, Jeff. If you consider Rust to be the small brother or the younger brother of C++, what do you think is the ultimate shelf life of C++ going forward?
I don't think it goes away, and I don't think Rust will ever replace it completely.
Interesting.
There's just there's too much there.
Legacy, okay, yeah, got it.
It's not just legacy. There's still certain things, and I haven't gone deep enough with Rust to know, like, as soon as I write some big Rust program, I'm going to find like 20 things that I like more about C++, I'm sure. Just because there's just so many more features in C++, right? Right. So there'll be something missing. That's been my experience with pretty much every language that I have to use. That's when I switch to something else, I'm like, oh, why does it, like, I was doing Go recently and there's no generics in Go. And I was like, oh my God, I just wish it was C++, right? So I'm sure there'll be things like that. Rust does have generics, but there'll be other things like that, that will keep C++ programmers using C++ even for new code. So I wouldn't go so far as to say it's only legacy. But I do think in general it's a good thing if slowly Rust takes over some of the C++ ecosystem, just because I think it's targeted at like the things that we really need, which is fast, secure programs.
I mean, C++ is now 40 years old. Strustrup, I think, started to develop the language in 79.
Right.
Give Rust a few more years.
I think
for sure, but I think
40 years mature, don't you, Chris?
But I think that's part of the part of my point is that like it hasn't gone away in 40 years, right? Yeah. And this is true of a lot of other like major languages. Like it's going to continue on because it already has 40 years of momentum, right? So for that reason, it will be hard to replace.
Never mind the large code bases written in C++, of course. Yes.
Yeah. Yeah. I mean, whenever you hear about these bugs like Heartbleed or things, you know, my non-programmer friends, whenever one of these hits the generic news or the general non-programming news, they go, why is there some bug from like this program in 1991 or whatever? And it's just like, because everything in computing is built on what happened before. So we have decades and decades of things going on. And it's like everything that's been built so far. I mean, some of it goes away and gets replaced, but it's not just C++, Python, all these major languages are going to be around for many, many more decades. And that's just the way things are, even if it's not the way things should be. So, but I do think that there are still cases where C++ is the ideal language. And I still have to put my disclaimer that I haven't gone deep enough with Rust. I could just completely change my mind next time.
We can do a follow-up episode next year, perhaps.
Yes.
Excellent. All right, gents. Final closing remarks from anyone? I think that was a great discussion. And as you've all said, the future of these languages is going to be there for a number of years to come. We've seen some of the upcomings of Rust. We've seen the variety and expanse of the libraries for Python. Yeah. So final remarks from anyone?
Maybe just this prediction thing. So if Rust will kind of increase a lot, and I see a lot of more Rust-based Python extensions, so that's probably what Python is good at. So it's existing already. There are some people who are fiddling around with a Python interpreter written in Rust, and right now you can also already write extensions in Python for Rust. So if Rust will take over more of this C++, C kind of field, as this low-level system language programming thing, then I will imagine that Python will have way more extensions that are written in Rust. And I think Python really focuses more on this application programming thing. And then you can take advantage of these libraries, and you don't have to dive. You have to actually know how Rust works. A lot of programmers are this field. They don't know Rust, but they can still use the functionality through an extension. And I think that's going to develop. It's not going to go away.
Okay, excellent. Yeah, no, that's a fair point, right? You say your analytics user or those kind of users of a programming language, then their primary focus is not to write a production-ready program. There is to get their problem solved. So an easier language. Yeah,
that's one big application area. So one big it's just a lot of people using programming as a tool, as part of their job, and they're engineers or some kind of things that they use it for problem solving. And that's a big part of the Python use cases. There are also people that are writing big applications in Python themselves. But I think by the numbers, there's way more people using Python as a tool besides other things they do.
Okay. Chris, final remark from yourself?
I reckon the whole bet basically centers around the ecosystem, right? I mean, that goes for C++, C, Python, Lisp, Rust, just to name a few languages, never mind Fortran and all the rest of them. If you can convince enough people to contribute to the ecosystem, you'll get that growth that PyPI has been experiencing for the last, 15 years. You get all these libraries, like Qt for graphical user interface, like the GTK, for low-level GUI stuff and so forth. and they are written in C and C++. And so going forward, programming will consist more and more of taking a look at what's already out there, and then how to solve the problem with already existing code. Needless to say, as we saw with Heartbleed and other stuff, that has a certain level of security implications, because if you're using code that you haven't written yourself, you don't necessarily know about the technical depth, never mind about the attack surface of this code. So it's a balance basically between simply reusing the existing code bases and quality assurance as in technical depth minimization, in terms of how much do you want to spend on making sure that the application does what you want it to, especially in a secure context. And I reckon this is essentially where Rust shines, because the ecosystem basically consists of Rust code, and you can be sure of, if a Rust compiler accepts a code base, it's normally to some extent vetted already. Because you cannot compile unsafe code, for example, in Rust. So for me, going forward, and it would be interesting to have the same conversation with the same people in about 10 years' time to see if the predictions were right or wrong, and to see where we are with regards to the surrounding ecosystems of these languages and basically how they're grown, and also basically if there are any favorites. For example, Mike, correct me if I'm wrong, but there are at least 3 or 4 web frameworks in Python, and nobody
you
kind of
300 web frameworks in Python.
300?
There are many.
Okay,
Yeah.
fair enough.
No, there's a few big ones, like Django is being the biggest one. Flask is maybe the runner-up, and then there's many others around.
Pyramid and so forth. Yes.
There's many new ones coming up because it's pretty easy, and they're getting better because they learn from the mistakes of the things. This always that's an advantage and disadvantage of open source, because everybody can roll their own. Yeah, and there's a lot of these frameworks out, and you don't know which of them is going to survive. Django is going to stick around because that's a big 200-pound or 800-pound gorilla, I should say, the big one. And a lot of people use Django. It's because it's very opinionated. Out of the box, everything works. And there are many more micro and mini or whatever frameworks you want to call them that have a different approach, and you can put things together. So that's like the web space, the application space in Python, and you have many new ones that some are very good in some particular kind of things. Now everything's getting asynchronous, and there are some things that you just can use REST applications like this, sending JSON back and forth, so to speak, and you don't actually have this HTML generation anymore on your backend. So there's many different ways to develop, and you will, in time, will tell which one is going to survive, which one turns out to be still relevant in 10 years. So, and I don't claim I can predict it. I just say we have to see how things are going.
It's all about the ecosystem. Yes, Jeff, over to you. Sorry.
Oh yeah. Well, I don't want to make any predictions about 10 years from now, but I do like what we were saying about Python being a language that's easy to learn, and I think like each of these languages has their own niche, and I do think like all of these languages can grow in their own way. Even though I did say I was hoping that Rust eats some of the C++ ecosystem or user base. I think 10 years from now we'll be in a situation where things are more aligned to the way they should be, because we have more options now, and the ones that are the right options for the right types of programs will naturally grow, or at least hopefully. I guess that's a Darwinian argument, but yeah, I just think things are going to get better and better as like all of these languages grow, as their ecosystems expand, and as people learn the right use cases for the right languages, right, and base less of their stuff on what was the legacy. So I think it's going to be a good place to program 10 years from now, or a good time, I should say.
Excellent. All right, I would just like to finally then say thank you very much, everybody, for your contributions today. It's been very insightful, and we'll hold you to that 5 to 10 years rerun of the episode to see where we got to with this.
Thank you very much for having me.
Thank you very much.
Pleasure indeed.
Very interesting discussion. Actually, I learned something today. That's always good.
And thank you very much for giving Rust a chance, Martin. That was a very interesting panel discussion, Martin. What do you think?
No. But yes, no, it was. I thought it was very interesting, and as per our news, it looks like Rust is on the way up. But yeah, likewise, as we all know, C++ has a large installed code base in many organizations, right? So it's not going away anytime soon. But yes.
But you see, if companies like Microsoft are actively considering doing new projects in Rust, there must be something to it.
Of course.
I mean,
New projects, yes, but if you think about certain software companies that are still running Python 2.7 as part of their code base, then you know what I mean, right? Then adopting something like Rust more globally is a long way off.
Agreed, but given the fact that C++ used to be the workhorse at Microsoft in terms of both operating systems as well as applications, that's I wouldn't say it's a bold move, but it's an interesting development. Let's put it this way.
Yeah, it's very significant. That's for sure. Yeah, coming from Microsoft, I agree with that. Yep.
Okay, and then it's onto feedback, right?
Feedback, yes.
Yes.
Okay, shall I go first? Or
yes, Martin, please.
Do you have an hour? Because we have
you can
some
feedback
from Greg J.
Yeah,
which is 20 pages long. So
why don't you just give us the highlights rather than kind of reading it all?
Okay, the highlights are if you believe in certain religions, then this is the article to read or the text.
Okay.
So yeah, you get the idea, right?
I do get the idea, yes. So in contrast to this bit of news, this bit of feedback, which was clearly not destined at Linux Inlaws alone, I'm looking at an email that Emma wrote. Emma wrote in. Emma is, of course, from Rainbow Escorts. During a recent visit, I had the pleasure of servicing Martin. Martin, you actually took my advice.
I don't know why she's writing to you.
Well, we come to that in a minute, but... Okay, listeners, for those of you who missed the last episode, Martin, let me give you the background of the story. Martin, again, tried to claim expenses for an escort service that he used, thus A, violating Linux Inlaws expense claim policies, B, accounts payable, wasn't too happy about it, so they got in touch with me and said, now look, have a word with your co-host, right? Which I did. And subsequently, Martin decided to actually follow my advice and use Rainbow Escort Services because we do have a corporate account with them. Perfect.
Is this something you instated? That was a good idea. You could have told me this.
Well, I did tell you, Martin.
Okay.
Okay. Again, during a recent visit, I had the pleasure of servicing Martin. Although most of his requests were nothing special, I see, Martin, a few of the things he desired were a bit on the unusual side. Interesting. Unfortunately, this is an explicit show, but the next couple of things that Emma writes are clearly XXX+, so we won't go into the details.
Okay, no, I thought you were going to say something about her reading chapters from the C++.
No. And actually, another very interesting observation. So we're going to skip the funky bits. She closed that feedback with, I quote, "Apart from his stunning physique and muscular stature, there are other parts of his body that make him ideally qualified for a career in the adult entertainment industry. More than happy to broker the initial introductions, etc." Martin!
I see. Don't you need to be sort of middle-aged and bald to be in this industry? Yeah.
Martin,
so you tell me. Anyway.
If this whole IT swindle blows, you're headed for the porn industry. How good is that?
I don't know. You tell me.
Money to be made, Martin.
Isn't that your side job?
No, it's not funny enough.
Okay. I thought since you're usually unavailable in the evenings.
Martin, just let me know if you're serious about this and a website can be whipped up on short notice.
I see. Yes, I'm sure these things can be arranged pretty quickly. But,
yes.
Let's stick with the IT side for now.
Coward. Well, Martin, imagine, you then kind of appearing on, what is the porn industry equivalent of the Academy Awards? I'm sure that there's something. And basically, once you win this, I can say I knew him when he wasn't famous.
I see. Do you think this is beneficial to the propaganda of Linux Inlaws?
Maybe. I don't know.
Well, if you agree that this is a, why don't you set the example, Chris?
Linux Inlaws as a breeding ground for budding porn stars. Interesting perspective there, Martin. Okay, Martin, if this whole startup GPU database business blows up, just go for it.
Thanks. Yeah.
I reckon with my current employer, who happens to be also Martin's previous employer, it's like a little bit of more time because we just had another injection of funds into the company, but that's beside the point. So maybe meet you on the other side in a couple of years' time. I don't know.
Other side of?
This is just an expression, right? Meet you on the other side in terms of meeting you on the set.
Isn't that when? I see. I thought when you expired.
No.
Yeah, that's the other side, surely.
No. Porn stars don't expire, Martin. Porn stars just go to a different sphere.
Okay.
In case you didn't know.
No, I didn't. Sorry. Not a subject I studied that closely.
Apparently, Martin, there's still a learning curve to master before you can venture into the adult entertainment industry. But given the fact that you're significantly younger than I am, there's still time to learn. So that's okay.
Excellent.
Okay, people. That's pretty much it. Unless Martin has anything to add about his second career choice. Or option, rather, not choice, but option.
It's probably more like the 15th rather than the second, to be fair.
Fair enough. Okay, people.
Yep.
We are on Hacker Public Radio, as usual. Credits go, of course, to Hacker Public Radio. Fair enough. Feedback can be sent to, like Emma did and like spammers do, apparently. Feedback can be sent to feedback@linuxinlaws, all one word, .eu. And for the time being, yes, you will find us on Hacker Public Radio. Should that change, you will be the first to know listening to this podcast. And see you at the next episode. Before we conclude today's episode, a shameless pitch for the upcoming big Halloween special at the end of October. We need your questions by mid-October, ideally open source related. Unfortunately, what are next week's lotto numbers or what's Emma's phone number only have a slim chance of getting answered. Simply send your questions to feedback@linuxinlaws.eu and listen to our Halloween special to hear the answers. This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Solid Market, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts. Hi.
Hello.
Mr. Visser, glad you could join.
Natürlich, kein Problem, ja.
Martin is pretending he's German. He's Dutch by origin, so I reckon we should stick to English.
The last name doesn't really tell. This can be a German name. I think that's nothing special about it.
Or do you think your Rust knowledge in German can muster up to the requirements, Mr. Visser?
Interesting question.
Yeah, okay, repeat after me. It's Rost. Yeah. It's R-O-S-T.
Rosti, yeah.
Rostig is the thing.
Okay, I think we're just waiting for Jeff and then we can get started.
Yeah. So, and I'm not familiar with the podcast. I have to say. So that's a Linux podcast. Is this right?
It's an open source podcast.
Open source, and more general, open source podcast.
Okay, yeah, maybe I should explain this. Or Martin, why don't you give it a shot in German? So, come on, Martin, try your German.
Okay, so die Linux-Innos sind zwei Leute, die sehr alt sind.
Very good.
Und die sprechen über offene Source.
Open software. I'm impressed. If my Dutch was as good as your German.
It's a long time since I've spoken any German, I have to admit.
Okay, Mike, just to fill in, this all started about almost a year ago in a small location in Prague, in the Czech Republic, where some nutters decided now it's time for a slightly humorous podcast, and hence Linux Inlaws was born. Mm-hmm. I don't know if a format named Linux Outlaws rings a bell. It was a podcast that started about 15 years ago, maybe less, by Dan Lynch and Pap Shashel of the H fame. And of course, Dan Lynch being one of the people behind something called OccCamp, one of the large open source UK unconferences, if not the largest. And then got ill and they terminated the podcast or shut it down, for want of a better expression, around 2014, 2015, something like this. And the Inlaws are pretty much a little bit of the legacy of the Outlaws. Mm-hmm. Slightly more on the communist side, more on the humorous side. But apart from that, keeping up the spirit of free and open source software.
Mm-hmm. Okay, yeah.
There's a beautiful homepage done by our own Mr. Visser at the linuxinlaws.eu domain.
Linux Inlaws. Okay, so I do right there. It's nice.
And now you know how Mr. Visser looks as a Martin.
Yeah. Okay, so
you two have met.
Oh yeah, we met. When did we meet first time around? Chemnitz, right? About maybe 2 years ago, maybe 1 year ago. I'm old.
Yeah, we met last year. We talked long on. Probably we met before. I think you met the year before also. But last year we were sitting there for an hour talking about things. I remember. So in Chemnitz, I talked to a lot of people. So, and I talked to a lot of. Usually when I'm traveling, talk to a lot of people. So I might forget it a little bit too. Whom I'm talked to.
Surely you didn't forget Chris. That's quite difficult.
Thank you.
Episodes.
Who needs Eddie's in this case? If you have friends like these.
and a nice radio here. The picture of the radio is from the 60s, I guess.
Yeah, full credits have to go to Martin because he did the lion's share of the website. I just kind of fiddled around with it a little bit here and there.
You've been listening to Hacker Public Radio at hackerpublicradio.org. We are a community podcast network that releases shows every weekday, Monday through Friday. Today's show, like all our shows, was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hacker Public Radio was founded by the Digital Dog Pound and the Infonomicon Computer Club and is part of the binary revolution at binrev.com. If you have comments on today's show, please email the host directly, leave a comment on the website, or record a follow-up episode yourself. Unless otherwise stated, today's show is released under a Creative Commons Attribution, Share Alike 3.0 license.